Okay. So first of all, we've been asking you for feedback every week about how we're doing, and to make sure you understand we're not ignoring you. Our indefatigable, is that the word I want? Research department, Connie, has gone through and pulled out the most common. There are 4 things that a bunch of people said that you wanted changed. We've kind of already talked about the first one, about people complaining about a disconnect between lecture and lab, and it's supposed to be like that because we're doing 2 things in parallel. One is teaching you how to program, and the other is discussing aspects of computer science that aren't just the practice of programming. So sometimes there will be labs that don't correspond to a lecture. Sometimes, as with recursion right now, when there's a really big, powerful idea that's about programming, there'll be lecture support for it. So you shouldn't be surprised when there's that difference. Second complaint, that some of the labs, especially lists, were too hard. And what we decided to do about that is we're going to start reserving some of the time at the end of each lab session to have a little mini discussion about the problems in that day's lab and what was hard, and go over some of them as a group. And we're hoping that that will help. There was a complaint about the programming. Yes?
Just wondering if I could open the door.
Sure. There was a complaint about the programming aspect of the quest, that it was hard to remember the names of the blocks or hard to draw the blocks. And yeah, that's true. The quest was somewhat limited by being a short thing in classroom. What we're thinking of for the midterm and maybe final is possibly to have the programming part of them be held in the lab and have you actually program, on a computer. If we do ask questions about programming on paper, we will provide sort of a list of the blocks we think you're going to need to use to help with that. So we agree with that one. And the 4th one was that there were too many questions about the reading. We kind of semi-disagreed with you. We think the reading is important, but we're going to interpret the question as indicating that we didn't really put enough class time into supporting the reading. So we're going to try to make sure that when there are readings assigned, one of the things that happens in discussion is some discussion of the readings. And we think that that will help. So that's the report on student feedback. I have a pile of people who asked for regrades, mostly on question 1, sometimes on question 4. And for the most part, I think I stand by the grading. You turned these things in before we had the solution and grading rubric online. I put notes on the things about why the grade is what it is. But one thing I want to say about that is a full credit grade on those reading questions, 1 and 4, the scale is that that's a really good answer. So if you got 6 out of 8, that's sort of perfectly expected and you're doing fine and you shouldn't worry about it. An 8 out of 8 is you really had a pellucid, clear, complete answer that cited the readings as appropriate and all of that stuff. Okay, so let's get on to the actual topic for today, social implications of computers. And I'm going to start with a clicker question. So I have to turn on polling. Here we go. So this guy on the screen is Elisha Gray, and I want to know who he is. No fair pulling out your laptop and Googling. A, inventor of FM radio. B, signer of Declaration of Independence. C, developed an early mechanical computer. D, inventor of the telephone. And E, an anti-technology political leader. Okay, going once. Going twice. Let's. Huh. Interesting. So nobody thinks he signed the Declaration of Independence, and you're right, he didn't. And the second least popular was inventor of the telephone. And the actual correct answer is Elisha Gray is the inventor of the telephone. So congratulations, 4 of you. He invented the telephone February 4th, 1876. That was the day he turned up at the patent office with his invention. Now, you all didn't pick that answer because you're thinking, wait, I know about the telephone. It was invented by Alexander Graham Bell. Watson, come here, I want you, and all that. Alexander Graham Bell also invented the telephone February 4th, 1876. So how come you know Bell's name and you don't know Gray's name? And the answer is Bell got to the patent office about 3 hours before Gray did. That's why. As it turned out, Bell's telephone didn't work as well as Gray's telephone. So after Bell got the patent, the telephones that the Bell Telephone Company actually built and sold used Gray's design. Okay, next question. This guy is Antonio Mucci. Did he invent FM radio? Did he invent the light bulb? Did he develop an early mechanical computer? Did he invent the telephone? Or was he an anti-technology political leader? Okay. Interesting. Either he invented FM radio or he invented the light bulb. So you've gotten the idea that we're talking about inventors today. As it turns out, Antonio Mucci invented the telephone in 1871. So that's 5 years earlier. But he did it in Italy, so it doesn't count. And that's why you never heard of him, although in Italy, people have heard of him, and there's a postage stamp about him, you know. But here in the United States, nobody knows about him. Okay, so what point am I making here? A lot of people invented the telephone at once. And this is almost always true in the history of invention. It happens because a new technology has certain enabling technologies that have to be in place before it can be developed. And once those things are invented, everybody figures out that, the next thing to work on is the telephone or whatever it is, and they all work on it, and they all get there at more or less the same time. But somebody wins the race to the patent office. So that's very different from sort of what we're all led to believe, which is some genius has some idea that falls out of the sky that nobody else has, and it's so amazing that that's why that person is entitled to patent it and have a monopoly on its use. There are a couple of cases like that where somebody has an idea that nobody else had. The one that everybody talks about is the Xerox photocopier, which was a technology that nobody else was working on. And in fact, nobody thought mattered. The guy who invented it tried to sell it to IBM, and they turned him down. Okay, so we're talking about what's called intellectual property. That's a pretty loaded name because of the word property. Here's what the Constitution says. The Congress shall have power to promote the progress of science and useful arts by securing for limited times to authors and inventors the exclusive right to their respective writings and discoveries. And I drew a box around for limited times because I want you to understand the nature of this provision in the Constitution. It doesn't say, if you have an idea, either an engineering-y kind of idea or an artistic kind of idea, that idea belongs to you innately by right, and it's yours forever. They could have said that. Right? They could have said, what comes out of your brain is yours, and we respect your right to use it in whatever way you want, to profit from it forever. The same as they say about owning a piece of land. Right? If you own a piece of land, it's yours forever, and you can pass it on to your children and your grandchildren and so on. It's just yours. But the Constitution doesn't say that about ideas. It says, in effect, we're going to make a bargain with creators in which we will give you a limited time monopoly to profit from your idea in return for you actually sharing the idea with us. And patents and copyrights are a little different. Patents are about inventions. Copyrights are about words or art. Patents were invented to solve a particular problem, which is the way inventors used to profit from their ideas was to keep it secret, keep their invention a secret, so nobody else knew how to make whatever it was. And the result of that is several times in the history of technology, someone has died and their secret died with them. So, for example, probably the most famous example, you've all heard of Stradivarius violins. And they cost tens or hundreds of thousands of dollars, or maybe millions of dollars by now, because there's only so many of them. Stradivarius knew how to make violins sound better than anybody else. He died. They can't do it anymore. Modern violin creators. Actually, just last year, there was a news report that some computer scientist thinks he's figured out the secret of the Stradivarius violin by doing analyses of exactly how it sounds. Playing notes, capturing the sound digitally, and analyzing it. He hasn't brought anything to market yet, but maybe, who knows. there are a lot of other examples that are less famous. If you're a painter, you would know stories more than I do, because I'm very vague on this, about particular colors that you see in art up to a certain point, and then you don't anymore, because nobody knew how to make that kind of paint. So the people who wrote the Constitution didn't want technology to disappear because somebody died. And so they said, okay, look, we'll make a bargain with you. You tell us how it works, and we'll give you a patent, not forever, but for long enough so that you can profit reasonably from having invented this thing. So when you go to the patent office, you can't say, I've invented such and such, but I'm not going to tell you how. You have to provide a working model and full disclosure of how it works, so that any competent engineer in your field, after reading your patent application, will be able to duplicate the work. The same thing is true about artistic creation. So think about plays and novels and paintings and movies and music and so on. And the people who create art get to benefit from it for a period of time. And then it goes into what's called the public domain, meaning that anybody can reuse it, can use that image in something else, or can write another story that uses your characters, let's say. And a lot of existing popular culture depends on that. So this is Disney's Snow White. Walt Disney didn't write the story. Who wrote the story? Brothers Grimm, I think. Yeah, somebody like that. What's happened in recent years is Congress keeps on extending the duration of copyright. Actually, very often at the urging of the Disney Corporation, because every time the first Mickey Mouse movie is getting to where it would have gone out of copyright, they extend copyright some more. So now it's well over 100 years. It used to be more like 20. And the irony is, if today's copyright laws had been in effect back when the Grimm brothers wrote their tales, we wouldn't have this movie. Right? Disney would not have been allowed to make many of the movies that they benefit from if the copyright laws that they benefit from had been in effect earlier. Yeah?
So if Disney wants to extend its copyright, they have to change the whole law? They can't just renew it?
You can renew a copyright once, is the current state of the law. But you can't just keep on renewing it forever. There actually was a court case after the latest extension of copyright. Some people sued to overturn that law on the grounds that Congress was effectively going against the limited time provision in the Constitution. So that the intent of the framers of the Constitution was not to allow 200-year copyrights. And that lawsuit failed. The Supreme Court ruled that although Congress can't pass a law saying copyright lasts forever, they can pass laws saying that copyright goes longer and longer and longer each time. What does this have to do with computers? Well, two things. One about copyrights and one about patents. So first let's talk about copyrights. In addition to legal protection, nowadays the owners of artworks have computers on their side. They've invented this thing called digital rights management, which you probably all heard about, which is software control of how you use. When you download something legitimately to your computer, you can only use it on that computer, or maybe the rules are more complicated than that. But there's some kind of rule limiting whether you can actually watch the movie or listen to the song or whatever it is. This DRM protection, digital rights management, is itself protected by law by something called the Digital Millennium Copyright Act, DMCA, which makes it a crime to find a technical workaround for DRM software. And this is bad because it actually, among other things, it raises the possibility of artworks becoming unavailable because the server that controls the digital rights management might, the company might go bankrupt or something, and your DRM permission times out, and then nobody can get to it. So the DRM battle has actually recently been won when it comes to music. Not because the law changed, but because people were so reluctant to buy something from, iTunes or Amazon or whatever, that, they just downloaded things illegally instead, not because of the 99 cents, but because of the DRM attached to their music. So now when you go to the Apple Music Store, the files that you download are not DRM protected. So that's a big victory that happened against increasing control over artworks. But the recent stance of laws has really turned against the idea in the Constitution about a bargain between creators and the rest of us. And now people in Congress seem to think about copyrights and patents as natural rights that should go on forever, and that should be protected against society in all cases. So it's made a kind of us against them state of affairs for users of copyrighted materials. The other problem about computers has to do with patents. There are a lot of patents about software. It's much, much easier to get a patent for software than anything else because other things you have to actually build a working model. So if you patent something about, the mechanics of airplanes, you have to bring an airplane to the patent office and demonstrate it flying in your improved way. But software, you just hand them a disk with the software on it. And the patent office has issued patents for some pretty trivial things. So everybody's favorite bad example is this little arrow cursor thing. Well, we actually don't use this technology anymore, but it used to be that the way it managed to redisplay what's underneath the arrow when you move it out of the way was to have the color of the arrow itself be an encoded version of the color of what's underneath it. It's called an exclusive OR. You don't have to know the technical details. All you have to know is somebody patented that. So if you have a cursor on your screen, the people who made your system are supposed to pay money to this patent holder. What's happened in practice is that it's now almost impossible to write software without tripping over some patent you don't know about. The big companies meaning Microsoft, Apple, IBM. Those are the really big ones. Generate dozens of patents a day, not because they're going to go out and sue you. That's not really what they're after. But defensively, so that if you patent something that they want to use and you go sue them or ask them for royalties, they can say, oh yeah, well you're violating these 200 patents of ours, and sort of brush you aside. So the big companies build up patent portfolios, which they then cross-license to each other. So if you're Microsoft, you don't have to worry about IBM's patents or Apple's patents or any of those combinations, because they all have agreements with each other, awarding each other free licenses to their patents. So big companies are okay. Little software developers have a problem because of this. And some of the patents should never have been issued in the first place. Some of them actually are for substantial inventions, but the length of patents is too long for software, because in the days before software, the cycle of creating the next invention took a long time, took several years. So you could patent something, you could enjoy your patent for a certain number of years, and meanwhile, people could be developing improvements to your, building on your idea, and by the time they were ready to market something, your patent would be expired and they could do it. Today, patents go on so long compared to how long a software development cycle is that it really holds back development. The other problem, besides the big companies having a monopoly on these patents, is there are other companies whose entire business is buying up obscure patents and suing people. So these are companies that don't make software. They don't make, MP3 players. All they make is lawsuits. And very often these lawsuits are ill-founded, but they win anyway, because intellectual property suits hardly ever actually make it to a trial. What happens is that people decide to settle. So it's kind of, pay me some money and I'll go away. And that's what happens. People pay these patent collectors to just go away and leave them alone. Okay, so that's the intellectual property story, and now I really got into clickers for this one. So, I have to turn this on, don't I, like that? Let's see how you guys... We're not going to turn you in to that.
We're recording your names.
By the way, to make sure you understand the difference between A and B, it's actually illegal to take a CD that you bought and rip it onto your computer. You have to officially download a new copy for your computer, download another copy for your iPod, and so on. And this is important because these days, if you cross a border, if you leave the country and come back in, they confiscate your computer and look for music or movies on it. And it's not good enough to say, well, look, I have the CD. Anyway, so how are we doing here? Okay. Interesting. 2 people chose E. That's the most interesting part. All right. So there's a disconnect between what you guys believe. That's the reason I asked you this. I want to see, what you believe about intellectual property, and voting with your feet you don't like it. So we could have a big, long discussion about, well, in that case, how do we support artists? Because, you know, we want artists to keep on being artists. We have to feed them. So people have some interesting ideas about this, but we don't have time because we have to go on to the next, I hope, topic. Hello? Okay, it's not listening to me anymore. Let's try this. Uh-oh, timeout. What is the problem? Oh, wait. Hello. Maybe that's the problem. Oh, yes. So you're watching TV, and here's this friendly family having a picnic on the lawn. This is, what we're looking at is my simulation of actual TV ads from the 80s. So here's this family enjoying their picnic, and all of a sudden, the evil Russians send a missile to blow them up. But have no fear, because they're going to be protected by the Strategic Defense Initiative. This was a Reagan-era bit of technology, mostly out of Lawrence Livermore, a lab run by the University of California. And their idea was to put up a bunch of satellites in space armed with weapons of mass destruction and programmed to look for missiles coming toward the US and blow them up out in space. I think they actually had some bombs in the satellites, but the weapon of choice for these satellites was super high power lasers, like in James Bond. And super high power lasers, by the way, is an ongoing research topic at Livermore. And partly it's for, you know, doing science experiment reasons, and partly it's for use as weaponry. As it turned out, by the way, the ad was a lie, because there was no way they were going to build enough of these satellites to protect this family picnic. What they actually wanted to protect was the US missile launch sites, so that if the Russians started attacking us with missiles, we would be able to blow them up in retaliation. Okay? And this was supposed to make them afraid to start a war with us, because, you know, if you're going to have a nuclear war, you want to do it really, really quickly so that you've blown up the other people's missiles before they have a chance to shoot back. And so the Strategic Defense Initiative was an attempt to ensure that that couldn't happen. Well, a bunch of computers, in this satellite, they were going to put software 10 times bigger than any program that anyone had ever written at that time. And sort of in the nature of things, you can't really debug it until it's up in space, you know, armed. So a bunch of computer scientists determined, just on technical grounds, that this was very unlikely to work successfully. And there was a serious possibility of a bug in the software that would shoot the laser, let's say, at the picnic instead of at the missile. And these computer scientists got together and started an organization named Computer Professionals for Social Responsibility. It was organized around this question of SDI, familiarly known, by the way, as Star Wars. Because the movie had just come out. So, and the CPSR people went and testified before congressional committees and so on, and actually were successful at that time. they and other people who were working against SDI for sort of sociological reasons as well as technical reasons actually convinced Congress to defund this project. The bad news is it's back. The folks at Livermore are still working on technology like this under different names. So far without much success, but there's a possibility that they'll eventually get to the point of having something they might try deploying. Because we've gotten better since then at writing software. So the software side of it is, although still very risky, I would say, not as out of the question as it was back in the 80s. CPSR still exists. I recommend their website to you, cpsr.org, Computer Professionals for Social Responsibility, as a source of information about both computers in war, which is what the organization started about, and other things like computerized voting systems, for example, was something that CPSR put a lot of energy into testing out. This is the current generation of using computers in warfare. This is a pilotless drone aircraft. So the airplane can be flying over, let's say, Afghanistan or Pakistan, and its pilot is sitting back in the United States with a joystick. The virtue of this, from the Air Force point of view, is that there's no risk of U.S. soldiers dying in this kind of war. So, if the people we're fighting against shoot down the airplane, we lose some money, but we don't lose any people. And that's important because in the United States, sad to say, most people only care about wars if it's Americans dying. So, on the news, when they tell you so many people died in the war in Afghanistan today, they mean so many Americans, not so many of the people who actually live there. And so if we can fight wars with absolutely no risk of loss of American lives, that makes it politically easier to make the decision to invade somebody. So that's sort of one of many ways in which computers are relevant to war today. So what do you think about that? Or, E, none of the above. Something else. Interesting. So there's more of a spread than on some questions, but most of you don't like war, which pleases me. I don't like war either. Okay, well, that was fun. All right. So I could talk about war all day, but it's depressing. So let's move on to the next question. What does it mean exactly to have 20,000 friends? So this is the topic of how computers affect human community, how computers affect people interacting with one another. And there's good news and bad news about this. So this isn't something like war where I'm coming in telling you it's all terrible. Has been an absolute miracle for people with communication disabilities, people who are blind or deaf. and who were very largely cut off from the human community because of that in the past, but now can participate in computer-mediated conversation on an equal footing. So that's the best thing about it. It's good that you can find your old friends on Facebook. That's cool. You know, reuniting the people you knew in high school 45 years ago, in my case, something like that. You can maintain friendships over long distances. So, you know, you had a bunch of friends in high school and you all went to different colleges, and that used to be kind of the end of it, but now you can stay in touch by email and so on. Crowdsourcing. You know what who knows what crowdsourcing is? No, okay. So you probably actually do know it, you just don't know the name. You have a problem to solve, and instead of getting one expert to sit down and solve it, you just throw it open to the whole world and figure that together people will figure out the best solution. The example that you all know about of crowdsourcing is Wikipedia. Right? So in old-fashioned encyclopedias, the publisher, for each article, hires some particular expert in whatever the field is to write the article. Wikipedia is not like that. Nobody's in charge of the article. Anybody who wants to can come in and edit it as part of a community with other people who are also editing it. So the very best crowdsourcing example that I know was after the huge tsunami in, I think, Sri Lanka. Many children got separated from their parents because everybody was running around, people got lost. And totally spontaneously, with nobody organizing it, people who were near there started taking their cell phones, photographing these children who were separated from their parents, posting them on Flickr, and using that as a way to reunite kids with their families. So, you know, that could not have happened a decade ago. And it's a totally wonderful thing, and a way in which computers have really helped the human community. The bad news is largely about privacy. So, you know, every so often there's a big Facebook scandal because they change the very complicated privacy settings in such a way that everything about you becomes accessible to advertisers. And then they say, oh, well, okay, we'll change it so that you can opt out of this. And then they do some other outrageous thing like that. But it's not just Facebook. Whenever you make a Google search, they remember your search. And they associate it with your computer. So they know which searches were made from which computers. How many people have Googled themselves from a computer they own? Okay, all you guys with your hands up, Google knows who you are. Google knows about all your, you know, kinky, weird interests. And furthermore, their records are sitting there waiting to be subpoenaed by, you know, the government if they should happen to want to investigate you. Maybe you think that doesn't matter, but a few years ago, some middle manager at AOL, which was at that time a much bigger internet service provider than they are now, decided to do a favor to social science researchers by taking, I think it was 20,000 or 200,000 or some number like that, search queries that people had made on AOL, replacing their AOL logins with, an arbitrarily assigned number to anonymize them, and then put that data out on the web. Because people tend to look themselves up, and using other similar kinds of reasoning about queries, it was a matter of hours before researchers had located the person who made the search request, how can I kill my wife? And also that was the most embarrassing one, but other really embarrassing queries about, for example, medical conditions and so on, were actually found out. The people, these specific people were discovered who had made those search queries. So it really is a big problem waiting to happen. AOL pulled it off, the next day, but it was way too late because, there are bazillions of copies all over the web. So privacy is one problem. Computer-mediated communication is sometimes not as good as face-to-face communication. People famously tend to flame on the net, right? Post really angry denunciations of each other. And one of the reasons for that is when you're talking to someone face-to-face, if I'm talking to you now, I can see your faces. If you're getting angry, I can tell, right? Very quickly. I can hear your tone of voice if you are in a conversation with me. But when you're just typing words, it's harder. So that's been a problem. Spam, enough said. And in some cases, an impoverishment of the actual face-to-face human community, because people spend their time on the computer instead of interacting with their neighbors. In one famous case, instead of interacting with his family, this guy got into a virtual romance with somebody on Second Life, and meanwhile he had an actual physical family that he never talked to. So, that's kind of an extreme case. So are computers democratizing? This is the last thing I'm going to talk about. We actually are going to make it on time for once. So people say that computers have been a democratizing force, and they point to things like the election of Obama, which was largely organized online, the campaigning effort. Protests in China, where some government bureaucrat does something outrageous and nothing happens about it until people start a big protest on the internet, and then the government gets embarrassed and fixes whatever it is. So that's the good news. The bad news for democracy, one piece of it is what's called gerrymandering. You know what that is? Gerrymandering? It's forming election districts with very peculiar shapes, designed to ensure the re-election of some incumbent, somebody who's in Congress, let's say. Gerrymandering predates computers. But today, because the voting registration records are online, they can tell down to the house if you're a Democrat or a Republican or something else. And so gerrymandering has become much more of a science and much more prevalent than it was before. Other things are more subtle. For instance, a lot of sites, like I read the Washington Post, and there's always a poll. Do you think we should send troops to Pakistan? Yes? No? The problem with that is it's a kind of pseudo-democracy, because you don't get to ask the questions. You only get to answer someone else's question. Turns out questions are much more important than answers. For one thing, by the precise wording of a question, you can elicit different answers from people. But also, whoever asks the question gets to decide what the important issues are. And some other issue that might be more important to you never gets posed at all. So that's kind of the downside about computers and democracy. So it's a yes or no, yes and no thing. It is democratizing in some ways, not in other ways. Finished right on time. See you next time.